You're right there, Larry.
We are now. Okay, the ignition source.
Here we will ignite a couple of wooden skewer sticks with a little butane lighter. Get the wood burning. Here we have bang sight, which is calcium carbide, CaC2, that reacts almost violently with water to form acetylene, C2H2. The equations are shown there. Once the acetylene is formed, when the water hits, it immediately burns to form CO2 and water, and also some soot, being a highly unsaturated hydrocarbon. Here we go. Water to bang sight. Whoa, look at that. See the sooty flame. The rerun, replay. Whoa, fun. Chemistry in today's flaming, hot, sooty world. Oh, more. More. Would you like some more bang sight? Yes, I would. Whoa, more. More. So much fun. Would you like more? Certainly. Oh. Now the product is harmless lime water, calcium hydroxide. The soot is evident on the walls of the beaker. Chemistry for today's world, and this reaction will power the Conestoga calcium carbide cannon in a combustion chamber that we will see momentarily.
Indeed we will, Tom. As usual, very well done. Let's see if I can see what the inside of that beaker looks like.
Harmless lime water, Larry. Much soot, elemental carbon. Conestoga, Bethlehem, Pennsylvania. Here is our carbide cannon, made by the Conestoga Company, which opened up for biz in 1912. This being June 2nd, 2012, 100 years ago. Cute little toy used by many a little boy for the big bang and explosion, safely done with calcium carbide in the form of bang sight. Calcium carbide, CaC2, is put into this simple but very clever little chamber where you put just enough in so that when you push this clever spring-loaded device, it lets out, oh, what would you call that, Dr. Bird? Maybe a match head's worth or 2 match heads worth of calcium carbide.
The requisite amount.
The requisite amount for explosion, safely done. Now, the carbide, calcium carbide, falls into water, which is in the combustion chamber. This is then sealed on, added, and a couple seconds go by. Then this little device, which is a flint, nothing more than a flint sparker. I'll show you how that works. Did it work?
One more time.
Let's do it again.
Good, good, good.
It makes a little spark which ignites the mixture of acetylene. Where does the acetylene, the C2H2, come from, you ask? The acetylene comes from the immediate reaction of the CaC2, calcium carbide, reacting with water to produce acetylene and a harmless, milky white, a solid called calcium hydroxide. And then the spark ignites the acetylene and the oxygen to make a big boom. And there's nothing fired by the cannon itself. This is open, but being open, a nice flame should shoot out the barrel with a rather loud, bassy, booming retort. So we will proceed to the backyard and do this in just a minute. This is the calcium carbide Conestoga Cannon, and I'll do an obligatory little limerick to introduce what's about to happen. CaC2 plus H2O forms a gas that burns with a golden glow. It's explosive affine, combusting so fine, and making the carbide cannon blow. Now, in a moment, I will introduce calcium carbide with this spring-loaded device. The calcium carbide crystals will fall into the water in the combustion chamber. I'll wait about 3 seconds, hit this plunger, which will make a spark that will ignite the acetylene formed by the powdery calcium carbide reacting with water. The acetylene will burn with air, cannon barrels open, it will go boom, and if we're lucky, we'll see a flame jump out of the end of the barrel. If I'm nervous, seem nervous, it's only because I'm nervous. All right, I will count to 3 or 4 after I push this spring-loaded device to put the calcium carbide in with the water. Okay? I've now done that. 1, 2, 3, 4. Here we go. Take 2. Bah! They got me, Marshall!
Tom.